Why won't it work? Why? Uncle, why did the circuit abuse? The thing did not work. Why? Uncle, why did my circuit not light up? Today we are going to be knowing why. If you build a circuit and then it does not light up, you are going to find out the reason and you are going to resolve it today. Okay? I am also going to know why certain things in your house are working, and if they get spoiled, what you can tell them to do so that it will be working. All right, so let's begin. We know that electrical circuits can only work if electrical current to which they are attached is complete. Okay, what we mean is that you know that electrical circuit can work if current is flowing, is it not? Yes. If your switch is off, will it work? No, it will not work. If your power source from where you are connecting it, your battery is dead, or your battery is flat, there is no power in the battery, will it work? No, it will not work, is it not? So if there is a break in the circuit, all these things I just mentioned are break. All right, it is incomplete and the device will not work. All right, so your electrical device will not work. Let's look at this example. Isang is holding his torch, okay, or his torchlight or his flashlight. Now Isang flashlight won't light up. What was really causing this problem? He is putting on the switch. Okay, the battery is the what? The cell, right? Then the wire is inside that is connected. Okay, so it's like a circuit as well, or is a circuit as well. Now he's trying to put on his simple flashlight circuit, and the thing is not working. What is causing this? What do you think is the cause? Let's find out. Now this is Tamara's reading lamp. It is not working also. What do you think is causing this problem? What do you think is causing this problem? Why is Tamara's reading lamp not working? Let's find out. The device in the picture are not working because there is a break, okay, in the circuit. I told you when there is a break, it means there is a problem with the connection. That current is not flowing completely. That is what we mean by a break. Now there are a number of things that can cause the break. Okay, many things can cause the problem. A few number of things. So we use switch to break a circuit on purpose, is it not? Yes, at your home. The reason why you put switch is so that you can break it, because you don't want the light on 24 hours all day long and all year long. Okay, first of all, you'll be wasting electricity. Not only that, the bulb will also be spent up before time. Okay, you use up the bulb before time, because all these bulbs, they have expiring period. Right, they have period they last. So when the switch is off, circuit is broken and the device will not work. I know you know this one already. These are examples of switch. Can you see it? Can you see it? Yes. Can you see it? Can you see it now? Yes, I want you to just have a picture of it. You can see it. So we do this on purpose, not like it's a fault. It's not a fault. Okay, so you cannot tell me that Isang switch is the reason why it's not working. No, it's not. Okay, you should know that. Incomplete connection will also cause a break in circuit. When a main electrical device is not plugged, okay, if it is not plugged, the connection to electricity supply is what? Is broken. That is, the device will not work. Why? Because let's say, for example, you want to watch DSTV, right? Now you put on your TV and your decoder plug is not properly plugged or is not connected. You put on your decoder, what will happen? It will not on, is it not? You now go and find out why is it not on. The first thing you check, what do you check? You normally check the source of electricity, right? By the time you check source of electricity, you discover that, oh, it's not plugged. So you now plug it and put it on. It now on, is it not? Yes. So also it is with other materials. Okay. Another one is when wires or other components are loose, or when there is something blocking the connection, the current is broken and the device won't work. Okay, so let's assume, what do I explain this now? Okay, let's assume you are at home. Say rat eat up a wire, and then you are not aware that rat has create a break in the wire. You now want to plug it. It won't work, right? You'll be wondering what happened. You might not be able to detect it until an expert comes. But as you are learning this now, you should know how to check for it, okay? Check for wires that are disconnected or broken, okay? If you find such wire, join them correctly. All right, you know how to join them correctly. Yes, the red will go to the red, the black will go to the black, okay? And the blue, if you have a blue, the blue will go to the blue as well. Now finally, what another thing that can cause it is that if the components or the devices are faulty, let me say for Tamara now the bulb is bad, okay, and for Insang also the bulb is also bad, or the battery is flat, okay, it will not work. So all these faulty components can cause break in a circuit. Flat batteries, broken or spent bulb, okay, gaps between the connection in the switch and then the broken wires, that is, you did not connect the wires well in the switch, okay. All this will make your circuit not to work. So if you know your circuit have not worked, after this class, go back and check all these faults and put it in order, okay, and give yourself the credit for being a good electrical engineer. All right, so there's what we call special circuit breakers. Special circuit breakers, we actually put them so that in case a high current is coming to destroy the device, instead of destroying the device, that circuit breaker will be destroyed, okay. An example is your fuse, okay. You put it in such a way that when a high current is coming, for example now your TV has a fuse, okay, I know the circuit you build does not have a fuse, but your extension, your plug, even your plug, those plugs that have 3 pin, there are some that if you turn them, you will see a mark where you can open. When you open it, you see a fuse there. I'll show you how a fuse looks like shortly. Now what does the fuse do? When the current is too high, look at a fuse. Can you see it? Look at this fuse very well. You can see a thin small wire in between the glass. Can you see it? Yes, you can see it. Now look at, this is the conductor, the first part and the other part. All right, now current will flow. You can see the red light showing you that current will flow through that wire. Are you seeing it? Do you see the red light just now? Yes, it's telling you that current will flow. Yes, it's showing you so that you see it properly. Current will flow through that wire to the other side. Now if the current is too high, that is passing through it to the other side, and if it gets to the other side, it's going to destroy things. Let me say your TV now. This is your TV. This is the fuse inside your TV. Now if the current is too high and it passes through, it will destroy the TV. Instead of destroying the TV, this thin red wire you are seeing now will burn. Have you seen that? Do you see that it has burnt? It will burn. So current will not pass through again. Current will not what? Pass through, and then your device will not be destroyed. All you need to change is just the what? Fuse. So whenever an electrical device gets spoiled, the first thing you need to go and check, you ask, does it have a fuse? If they tell you yes, is it high current that came? They said yes, you already know that it is a fuse that is bad, is it not? You just go and check the fuse, and then you remove the fuse and replace it. They sell this fuse in the market. All right, you just need to look at the body. On the body they write the ampere or the current, okay, and then you buy it and replace it. It's very easy to replace it. Just tack it inside. All right, I want you to watch this video and gain more understanding on how to fix faulty devices.
When your dryer, vacuum cleaner, blender, or any other appliance suddenly won't work, most people do one of two things. Either they throw it away and pay for a new one, or they pay almost as much to have someone spend 15 minutes to an hour to fix it for them. There is a third option that has been forgotten by many. Fix it yourself. After all, most people didn't learn about circuits in school, although maybe we should have. It's extremely valuable information. An appliance can look a little intimidating sitting there looking pretty in your kitchen or laundry room, but actually, most are fairly simple machines made up of a collection of mechanical devices and circuits. The home appliances that we use every day are not magic boxes. They operate by basic rules. Understand those rules, and suddenly what was a huge expense becomes an interesting puzzle. Understanding how a circuit works will give you the confidence needed to save more of your... An electric circuit is a path or several interconnected paths capable of carrying an electric current. Most circuits have four basic parts: a power source, conductors, a control device such as a timer or switch, and a component such as a light bulb or motor called the load, which offers resistance to the circuit. Wires act as the conductor, carrying electric current from the power source to the component. To provide an element of control, a switch of some sort is normally installed. And lastly, a safety device such as a fuse or breaker is used to protect against trouble. There are three basic problems that can occur with an electrical circuit: a shorted circuit, a grounded circuit, or an open circuit. Simple. The key is to learning how to read the signs. Shorted circuits, grounded circuits, or open circuits can all occur within the conducting wire, component, or a control device such as a switch, thermostat, or timer. Let's take a look at this basic circuit, enclose it in a grounded cabinet, and use it to demonstrate the three most common types of circuit problems that can occur. First, a shorted circuit. A short circuit happens when two bare conductors come in contact with each other. The current no longer flows through the entire circuit. It is shunted from the hot conductor to the neutral conductor and bypasses the load wires. Because the circuit is properly protected, the fuse or circuit breaker reacts to this increase in current or amperage and blows or trips, stopping the current's ability to flow. To correct a short, the damaged conductors or component must be located and repaired. Then the circuit breaker can be reset or the fuse replaced. That was easy. So now let's look at a grounded circuit. It is a common safety practice to connect the cabinet of an appliance or other major components to a ground source. Electricity will always take the path of least resistance to ground. You do not want to be that path. So, this connection helps to protect the user from electrocution in the case of a short. A grounded circuit happens when a hot wire comes into contact with the cabinet or grounded part. When this happens, the circuit is again shunted to a neutral connection, in this case ground. The load is bypassed, the resistance decreased, the amperage increased, and you know the rest. See, it's pretty simple. We locate the problem, fix it, reset the breaker, or replace the fuse, and bingo, you're back in business. Lastly, an open circuit. An open circuit happens when a conductor or component breaks or burns out, opening the circuit and blocking electricity's ability to flow. When this happens, resistance is increased, so, according to Ohm's law, current must decrease. An open circuit is just like opening a control switch. No current is allowed to flow. This is the most common type of electrical problem associated with appliance repair. If any part within the circuit fails, the continuity or electricity's ability to flow is broken, stopping the flow of current. Replacing the defective circuit component or conductor will get you going again. At this point, a few questions need to be asked. How do I know which of the three types of problems I'm dealing with? Once I know what I'm dealing with, how do I locate it? Lastly, once I've found the problem, how do I fix it? There are a few things you can do right off to locate it. There are two main types of circuits having the same key elements: a power source, conductors, load, and a control device. The two types of circuits are series circuits and parallel circuits. Series circuits are formed when two or more components, or loads, which offer resistance to the circuit are placed in series. When a problem such as the ones I described earlier happens, the entire circuit fails. The other style, a parallel circuit, is when two or more components or loads are placed in parallel. In this style of circuit, depending on where the problem occurs, one component may fail while the other components remain unaffected. Many appliances use circuits that have both styles in one circuit, and this is called a series parallel circuit. Now you may be saying, you said this was easy. Anything worth doing takes some time and practice to master. Now you know the four key elements of a circuit, and the three most common problems that can cause your appliance to call in sick. This is a solid foundation of information to get you started. Most appliance problems happen when a particular component fails to work properly, or a control device like a thermostat, door switch, or timer fails to open or close when it should. Each of these component failures gives clear signs as to the cause of the problem and where to start looking. The easiest way to troubleshoot most appliance problems is by these symptoms, such as a dryer that will run with no heat, a refrigerator that is cold in the freezer but not the fresh food section, a washer that does nothing when it should spin, or a dead dishwasher. These clues will tell you where to look, and with a little practice and help from your humble technical assistant at applianceassistant.com, you are well on your way to experiencing the satisfaction that comes from solving your own home appliance problems. Remember, you can do it, and we will show you how.
Welcome back. I hope you enjoyed that interesting video. Now, we've learned in this class that an electrical device will not work if there is a break anywhere in the circuit. And we also learned that we use switches on purpose to safely break and complete a circuit so that we can put it off and put it on. All right. And you also saw the use of fuses. Okay. That brings us to the end of today's lesson. I want you to do your assignment. I'll see you in the next class. Stay safe.